President Trump has introduced the first picture to be shown straightforwardly from the James Webb Space Telescope. Under the colossal oceans lie mysteries that beat inventive minds. Excerpts of lost history, creepy signs of something continuing on a deeper level once thriving. These are fit to be uncovered at this point. Amidst the appeal of divulgence, there's a splash of disquiet. Consider the plausibility that these secrets were never planned to be found. Dive with us as we jump deep into 15 lowered exposures that have left even the most fearless explorers shivering. Plan to be both charmed and scared. The launch of the James Webb Space Telescope in 2021 was an incredible event. It took off very high atop a strong Ariane 5 rocket amidst the rich forests of South America, adding a little bit of nature's greatness to the occasion. Countless analysts from around the world had poured their total skill and effort into this undertaking for many years, coming to fruition in this monumental achievement. However, such marvelous endeavors come with epic risks, and the chance of failure represented a potential danger. Sublimely, everything spread out with near-perfect precision. The telescope set out on a trip, navigating nearly 1,000,000 miles, enduring 30 long days of travel through the void of space. Its conclusive goal was the perplexing Lagrange point, a spot in space where gravity keeps a delicate balance opposite the Sun as per Earth's orbit. This spot had already become home to other space telescopes like the Hubble Space Telescope and the Spitzer Space Observatory, making it an ideal vantage point for the James Webb Telescope to begin its endless excursion. As the James Webb Space Telescope set out on its journey, NASA unveiled its aggressive plan outlining key spaces for examination. As a matter of some significance, the telescope was designed to observe the universe's first emission of light, a pivotal junction in cosmic history. It attempted to test the old, wonderful past, revealing the secretive gathering of universes during the universe's early stages. Beyond this limitless, obsolete investigation, the JWST was also equipped to uncover divine presentations of exceptional significance. It longed to explore the birth of stars, uncovering insights into the start of stars and the development of protoplanetary systems. Furthermore, its process extended to the scene of planets, diving into the astounding story of planetary existence, including the fascinating beginnings of life itself. These legitimate edges had long escaped extensive examination due to the inherent challenges of studying the universe. Before embarking on its heavenly discoveries, the JWST went through a meticulous series of consistent tests and calibration procedures, including the sending of a surprising protective shield designed to protect its delicate instruments from the constant assault of the sun's heat and blinding splendor. Given the telescope's relentless journey through the astronomical void, this shield was essential. The Sun Shield, a huge structure made from 5 thoroughly layered films, had been carefully folded like a complicated accordion. The unfolding process required an accurate development of steps, ensuring proper tension and arrangement of each and every layer. The stakes were immense, as any misalignment or damage to this enormous guardian could risk the telescope's ability to see the faraway, frustrating spaces of the universe. With assistance, it traveled through the initial tests, preparing to reach the next test, the impending task of opening the telescope. Another highly delicate procedure, not with understanding the fact that it was already fully deployed, required careful planning to fulfill its endless commitments. At the core of the JWST lay its primary mirror, a complicated mosaic of 18 hexagonal pieces that required optimal synchronization to create sharp, high-quality images. The preparation of the JWST was a ballet of complexity and delicacy, involving not only the unfolding of its immense sun shield, but also the easy assembly of its support structure and the gradual revealing of its primary mirror. However, the mirror's exposure marked only the beginning of the awesomeness. Every part needed to change perfectly to enable the JWST to fulfill its scientific mission. Another complicated test involved exciting the Webb scientific instruments independently, like mixing lazy sensors. These instruments included the near-infrared camera, the near-infrared spectrograph, and the mid-infrared instrument, each having unique capabilities for studying the universe. Just as important was the telescope's orchestration of its limitless direction, a collaboration known as charging. This involved engaging the telescope in focusing on change markers and refining its point, ensuring that its instruments were locked onto key areas with pinpoint precision. These trials served as the gatekeeper at the door, ensuring that the Webb telescope was ready and prepared to embark on its odyssey and uncover hidden insider secrets of our universe. As these unusual systems unfolded, a sense of anticipation swept throughout the scientific community. Everyone held their breath, awaiting success, knowing full well that, in the realm of science, things often don't go as planned. To everyone's amazement, the JWST passed every test flawlessly, an achievement that is truly astounding. This spectacular mission united more than 300 universities, affiliations, and organizations from 29 states and 14 different nations. Then, in July 2022, after continuing on and overcoming each challenge, NASA gave the James Webb Space Telescope the approval to embark on its brilliant scientific journey. NASA proudly declared that all 17 of the observatory's scientific instrument modes had gone through exhaustive assessment and were now deemed ready for action. Like any other telescope, the JWST's primary job is to gather and focus light, revealing faraway cosmic wonders. However, what makes the JWST unique is the specific slice of the electromagnetic spectrum it observes. While our eyes are limited to seeing visible light, the JWST can pass into a secret space of infinite quality. It is a tremendous shift in perspective, opening new horizons as we continue our pursuit of understanding the universe. The James Webb Space Telescope resembles an innumerable power searcher, like a cutting-edge night vision camera capable of exploring the universe's depths. Its enormous size allows it to collect more light than any other telescope, enabling it to peer at much smaller, farther away cosmic wonders. But here's the greatest part. It's situated in space, free from the inconvenient atmospheric street blocks that often obscure our view. That's why they call it the universe's careful focus. So how does this marvel really work? At its heart, it displays a legendary 21-ton reflector. This beast reflector captures and redirects light back to the telescope's diverse instruments. Speaking of instruments, the JWST carries a collection of 4, each with its unique specialized capacity. First, we have the near-infrared camera, the JWST's primary eye. This cutting-edge lens captures dazzling pictures of faraway galaxies, nebulae, and other cosmic wonders. Next is the near-infrared spectrograph, like a giant gem separating light into its rainbow shades, revealing crucial insights about the objects it observes. Then there's the mid-infrared instrument, specially designed to collect infrared light. It dives into the secrets of the early universe, examining exoplanets and even taking a closer look at our own nearby planetary system. Finally, there's the fine guidance sensor, near-infrared imager, and slitless spectrograph. These high-precision gadgets ensure the JWST maintains stable course and is also sensitive to incoming infrared light. With this combination, it leaves no stone unturned. Now, the real magic lies in understanding the expanding universe. As the universe grows and stretches, light from faraway corners of space gets redshifted. This means the light's frequencies become relaxed, causing it to appear redder than its original form. By observing the universe in this redshifted light, we can literally peer back in time, seeing the universe as it was in its earliest days. Imagine witnessing the birth of stars and galaxies and learning about the early conditions of our universe. The James Webb Space Telescope can look deeply into the universe, an achievement that truly allows it to appear back in time. The farther an object is from us, the longer its light takes to reach us. When the JWST focuses its instruments on a distant galaxy, it's not just capturing a snapshot of the present. Rather, it's like a self-important time machine, revealing what that galaxy looked like billions of years ago when its light began its interstellar journey. This remarkable ability allows researchers to study the ancient history of our universe, back when the first stars and vast galaxies were forming, providing a precious opportunity to study the processes that shaped the universe we now observe. The capabilities of the JWST made their grand entrance into the public eye on July 12, 2022, following NASA's revealing of its first batch of imagery during a live event. These photographs were nothing short of astounding. Imagine gazing at the cosmic cliffs inside the Carina Cloud or marveling at the ethereal magnificence of the Southern Ring Nebula. These were more than just beautiful images. Those photos were windows into the infinite richness of reality. However, that's not all. The telescope went beyond aesthetics, delving into the scientific goldmine. It analyzed the atmosphere of the burning gas giant exoplanet WASP-96b, offering fundamental insights into distant worlds. It also presented us with a charming view of Stephan's quintet, a group of galaxies locked in a mesmerizing cosmic dance as they mix and collide. These photos didn't only spark excitement due to their visual splendor, although they certainly did, but they also ignited enthusiasm because of the profound scientific revelations they brought. It was as far back as February 2022 that NASA first gave the world a brief look into the JWST's remarkable capabilities. This was when NASA announced Webb's debut view of starlight. The image, a mosaic made of 18 scattered shining specks, highlighted the prominent star HD 8446. Thomas Zarin, NASA's Associate Administrator for the Science Mission Directorate, excitedly tweeted that as the Webb honed its center, these 18 divine aids would eventually come together into a single bright star. This achievement marked an exhilarating milestone, representing the telescope's vast potential for future discoveries and interstellar investigations. In the following weeks, Webb continued its odyssey of progress. On February 18th, NASA unveiled an updated picture of HD 8446, where the 18 scattered star copies had been carefully aligned into a stunning hexagonal pattern. This gave us an enticing glimpse at the potential magnificence that awaited once the observatory precisely adjusted the individual parts of its primary reflector, marking the dawn of image stacking and promising even more magnificent discoveries. What makes this exoplanet truly stand apart among its sublime associates is its sheer size, a behemoth among giants. As the James Webb Space Telescope, JWST, embarked on its journey, analysts and cosmologists eagerly awaited its next set of exposures. The JWST's advanced instruments were designed not just to capture images, but also to investigate the spooky signs of faraway celestial objects. This capability allows the telescope to detect the composition of cosmic matter, offering insights into the materials that make up distant galaxies, stars, and planetary systems. One of the most anticipated features of the JWST was its ability to peer through vast clouds of gas and dust, a critical task for focusing on areas where stars and planetary systems are born. Infrared light, which the JWST is specifically tuned to detect, can penetrate these clouds much more effectively than visible light. This means the telescope could observe the early stages of star formation and the complex processes related to planetary system development that had previously remained obscured. Additionally, the JWST's ability to analyze exoplanet atmospheres represents a major leap forward in exoplanet research. By studying the light that filters through an exoplanet's atmosphere as it passes in front of its host star, scientists can detect chemical signatures of various elements and compounds. This method, known as transmission spectroscopy, allows experts to determine the atmospheric composition of exoplanets, including the potential presence of biomarkers or artificial markers that might suggest the possibility of life. The telescope's observations are also expected to provide new insights into the development and progression of the early universe. The JWST can study light from some of the earliest galaxies formed after the Big Bang, offering a closer look at how these galaxies evolved over time. This data will assist researchers in refining their models of cosmic evolution, including how galaxies merge and grow over billions of years. Beyond its scientific objectives, the JWST serves as a marvel of engineering, showcasing human ingenuity and collaboration on a global scale. Its development included numerous technological advancements, including its deployable sun shield and its segmented primary mirror, which had to be precisely adjusted after launch. These advancements represent the perfection of many years of creative work and have set new standards for space telescopes. Additionally, the data gathered by the JWST will be instrumental in advancing our understanding of key astrophysical processes, such as the interactions between dark matter and ordinary matter in large-scale galaxy formation, or understanding the life cycle of stars, from their formation to their ultimate demise. The James Webb Space Telescope, JWST, continues to unlock mysteries that were once beyond our reach. Its extraordinary ability to observe in the infrared spectrum enables it to peer through dust clouds and see distant, faint objects that would be invisible to optical telescopes. The high-resolution images it captures allow astronomers to explore objects that are billions of light-years away, some of the earliest galaxies that formed after the Big Bang. This offers a window into the universe's infancy, providing clues to how galaxies, stars, and planets came to be. What's more, JWST's design allows for deeper analysis of cosmic phenomena that have remained enigmatic. By studying the chemistry of distant worlds, scientists can explore the building blocks of life and search for the signatures of habitability on exoplanets. Its precise measurements of distant galaxies also contribute to our understanding of cosmic evolution, potentially shedding light on dark matter and dark energy, forces that make up most of the universe's mass and energy but remain largely undetectable. In essence, JWST is more than just a telescope. It's a time machine that lets us trace the origins of the cosmos. It provides an invaluable tool for understanding how the universe has developed over billions of years, unraveling secrets that were once thought impossible to uncover. The mission of the James Webb Space Telescope is not just about observing the stars, but about connecting us to the very fabric of the universe itself.